Hello everyone, welcome back. Today we are going to discuss about the topic conversion of epsilon NFA to DFA. In the previous lecture we have discussed about conversion of epsilon NFA to NFA. Now we will be discussing about epsilon NFA to DFA. Let us have a quick recap of what is epsilon NFA and DFA. Coming to epsilon NFA, as we already discussed, so it is the automata which is moving upon accepting epsilons, that is which is moving upon from one state to another state on a null move, whereas DFA does not accept any null moves, and when a DFA has to transit from one state to another state, it has to move upon a specific input symbol, and the path that is mentioned in the DFA is also said to be deterministic. Coming to this epsilon NFA and conversion into DFA, here it involves epsilon closure. There is a definition that is to be known about, because when you are converting an epsilon NFA into a DFA, in the epsilon NFA we will be having several paths that are reachable from a particular state to the other state on epsilon. So if you see the figure, that is a transition diagram here. From state 1, we are moving to state numbers 2 and 4 on epsilon, and from state 2, we are moving to 3 and 6 on epsilon, and in 5 also we are moving to 7 on epsilon. So if we consider the starting state, when you are converting the starting state and considering this epsilon NFA to convert it into DFA, our DFA can either start from this state 1, or it can start from state 2, or it can start from state 4, or it can start from state 3, or it can start from state 6. That means there are several alternatives for the DFA to choose. So what here we have to do is, we are making an epsilon closure of all these states so that we are marking it as a single state for the DFA, because as DFA, as per its definition, it is said to be deterministic. Now coming to the definition of this epsilon closure of a particular state is defined such that the set of states which are reached from Q along the path labeled on epsilon. So if you see here, epsilon closure of state 1 in level 1, so we will be reaching to the states 2 and 4 on the epsilon move, and in level 2, that means increasing the levels of closure here. So from level 2, again you are having an epsilon move onto the state 3, and in another level, that means in the next higher level, we are having another epsilon move on the state 6, from 3 to 6. So epsilon closure of 1 includes 1, 2, 4 in the first level, and 3 in the second level, and 6 in the third level. So combining all them, that means making a union of all of them, will be getting epsilon closure of 1 as 1, 2, 4, 3 and 6. Similarly, for 2 also you can find, that means epsilon closure of 2 will be from 2 to 3 and 3 to 6. Similarly, for 3 it is from 3 to 6, and for 5 it is from 5 to 7. Where this is nothing but the epsilon closure. We have to find the epsilon closure because we are going to predict to the DFA a particular state where it will be making exactly one transition on the input symbol. Now, after finding this epsilon closures, we'll be using a function known as extended transition function, where this extended transition function will be defined on a particular string. Now, difference between the transition function and extended transition function will be allowing us to move upon a particular string. That means if you are having a set of symbols, on that particular set of symbols, we can perform the transition function, whereas normal transition function that we are using in the DFA or NFA will be using only a particular transition on a particular single input symbol, where here you can have combination of, that means string may represent a single character or a multiple characters. That is nothing but it can be a single element in the input alphabet or multiple elements in the input alphabet, or sometimes it may be also epsilon, that is the input symbol, which is nothing but treated as a null. So now we'll see the transition function on delta cap of 2 comma epsilon. So another important point here is transition function is simply represented by delta, where extended transition function is represented by delta cap. So delta cap is used to represent the extended transition function. So coming to delta cap here, so delta cap of 2 comma epsilon, that is, this is nothing but extended transition function. So the extended transition function is defined as, it is nothing but the set of epsilon closures that you have obtained on a particular state on the input string that is given here. So here on epsilon, 2 on epsilon, it is moving to 2, 3. From 2 itself, it is moving to 2, 3 and 6. So we'll be finding epsilon closure of these 3 states. So that is epsilon closure of 2 union, epsilon closure of 3 union and epsilon closure of 6. So finally we'll be getting the states as it is 2, 3, 6, where this state we'll be marking as new state of the DFA. Now coming into the conversion process here, so first of all, as we already discussed, we are going to construct epsilon closure for the starting state of the NFA, because as we told earlier that NFA, which is moving upon epsilons, is having several alternatives, whereas DFA should be deterministic. It should move on a single state. So what we'll do is we'll construct epsilon closure for the starting state of NFA and we'll make it as the initial state of the DFA. Now from the initial state, we'll obtain the transitions on the input symbols of the DFA by using this extended transition function and making union of all such states. And whenever you are coming across a new state here, then again we'll be finding the transitions by repeating this particular step 2 what we are having. And these two steps, that is step 2 and step 3, are repeated until we will be reaching across a state something like there are no new states in the transition table of the DFA. Now, finally, what is it we have to do is, in order to say that our DFA is accepting the input string, we have to mark the final state of the DFA. Now, coming to the final state of the DFA, that is nothing but the final state of this epsilon NFA is marked as final state of the DFA. Now, let us have a look about the example here. Coming to this epsilon NFA here, so there are two epsilon paths specified on the states Q0 to Q1 and Q1 to Q2. Now, we'll find out epsilon closure of all these 3 states. That is, for epsilon closure of Q0 is Q0 to Q1 and from Q1 to Q2. So we'll label this Q0, Q1, Q2 here. And then epsilon closure of Q1 is Q1 to Q2, that is Q1 and Q2, where epsilon closure of Q2, there is no move, so that is the state itself will be written like this. Now, the set which is initially we have obtained, that is initial state of NFA is Q0 and epsilon closure of this NFA is Q0, Q1, Q2. This is made as new state of the DFA. So, for example, we have labeled it as A. Now, after that, what we have to do is we have to find transitions on the state A. Now, finding transitions on the state A for the input symbols 0 and 1. So, delta dash, we are computing this delta dash, that is extended transition. Delta dash of A comma 0 is epsilon closure of delta of Q0, Q1 on Q2 on 0. That is Q0 on 0 union, Q1 on 0 and Q2 on 0. Where Q0 on 0, it is there is no move and Q1 on 0 is moving to Q1 and also on Q0 and Q2 on 0 is remaining in Q2 itself from the transition diagram, that is NFA. So that is Q0, Q1, Q2 again, which is nothing but A. Now finding the transition of A comma 1, that is the state from state A, we are finding the transition on the input symbol 1, it is epsilon closure of Q0, Q2 and Q1 on 1, that is Q0 on 1 union, Q1 on 1 and Q2 on 1. So we are obtaining a new state here, that is Q0, Q2, which is nothing but treated as B. Now representing the diagram here, A on 0 is A and A on 1 is moving to B. Now from this state B, we have to find the transitions. Similarly, delta of B comma 0, that is Q0, Q2 on 0, we are finding Q naught on 0, there is no transition, and Q2 on 0 is Q2 itself. That is, we come across a new state C. And B comma 1 is nothing but Q naught Q2 on 1, where Q naught on 1 and Q2 on 1, we are making the union of them. That is, Q naught on 1 is Q naught again, and Q2 on 1 is Q2 again. That is, Q naught Q2 we have obtained, which is B. Now marking the transition diagram again here. So B on 0 is moving to the state C, and B on 1 is remaining in the same state itself. Now C is the new state that we have obtained, and we have to find transitions for C here, where finding the transitions for C, that is Q2 on 0 is Q2 and Q2 on 1 is also Q2. That means we are in the same state itself. So that is Q2 on 0 is Q2 and Q2 on 1 is also Q2, where Q2 is nothing but we are labeling it as C. So we have not founded any new state in this step. So we can just stop the process. That means now we have to mark the final state as C, because Q2 being the final state in the epsilon NFA, C will be marked as the final state in this particular NFA. And the transition diagram, if we observe here, so from state A, on input symbol 0, it is moving to state A, and on input symbol 1, it is moving to state B. And in state B, on 0, it is moving to C, and on 1, it is remaining in the state itself. And on C, on 0, 1, it is remaining in the states C itself. Thank you.